There are telescopes searching the skies for signals, for hints, for a sign of civilizations or even the signals from starships moving through the sky. Usually, radio waves aren't all that strange. On the flip side, they shed light on the universe's inner workings that would otherwise remain hidden from our naked eyes. As we sit on a spiral arm of the Milky Way galaxy, these radio signals shed information on the origins of other galaxies, stars, allowing us to piece together our own cosmic narrative. But fast radio bursts coming from the vicinity of a nearby galaxy, one of the last places astronomers expected, is very shocking and one of the biggest mysteries in astronomy. From where do these radio signals originate in space? Are they aliens inclined? Should we be alarmed? Join us as we explore the mysterious signals we have been receiving every 22 minutes for the past 35 years. In its 1933 article about mysterious radio waves from space, the New York Times noted a crucial disclaimer: no evidence of interstellar signaling. Indeed, the radio waves weren't signals from aliens. After all, it's never aliens until today, some 90 years later. Actually, radio waves, a form of energy or light that is naturally generated across the universe, are continuously bombarding our planet. Discovering intriguing, incredibly distant events like stars exploding or black holes during cosmic dust through the use of radio waves is incredibly valuable. And this is achieved by employing massive dish-shaped antennas many light-years away in galaxies that are nearly unfathomably remote. Are the sources of these observed radio waves? We imagine them as soft murmurs carried by the wind. That is why enormous antennas are needed by astronomers in order to detect them. One of the most prominent radio emitters in the sky would be your cell phone if you were to place it on the moon. These are very faint signals. The amount of energy collected in radio astronomy's history is less than the energy needed to melt a snowflake. But they still show us huge things that have happened in our galaxy and others. It could appear as though the enormous expansive dark void of space is remarkably silent. That is correct when viewed through the medium of visible light, which has substantially shorter wavelengths compared to radio waves. However, when viewed through radio waves, the cosmos appears chaotic and is undergoing incredibly energetic occurrences. Identified for the first time in 2007, fast radio bursts, FRBs, are incredibly bright and short radio wave bursts that can come from billions of light-years away and have so far defied explanation. A globular cluster located 11.7 million light-years from the neighboring spiral galaxy M81 has been associated with a recent rapid radio burst. This explosion was found in the middle of an old star cluster, which is as illogical as finding a smartphone within Stonehenge. Even if they did exist, fast radio bursts probably wouldn't be here. So what's going on? Hundreds of thousands of quick, strong bursts of radiation shoot across the sky every day and night. Despite being undetectable to the human eye, numerous fast radio bursts can briefly eclipse all other celestial objects when observed with a radio telescope. Because they happen beyond the range of radio telescopes, the vast majority of bursts go unrecognized and never return. We have now discovered the farthest fast radio burst ever detected, a pulse that is 8 billion years old and has been traveling for over half the universe's lifespan. The first is that nobody knows what's causing them. Pulsars, which are rotating neutron stars in our galaxy, are the closest thing to these bursts, although their energy is 1 trillion times higher. The second justification is that bursts give a fresh instrument for investigating other facets of the universe. Fast radio bursts allow us to examine the intergalactic cosmic web of stuff. The fast radio bursts are gently slowed down as they pass through this substance, which is a gas that is both invisible and extremely hot. A burst's rate of slowdown is proportional to its distance traveled. Research into very fast radio bursts in 2020 disproved the long-held belief that the cosmic web was missing half of the universe's regular matter. Also, for almost 30 years, an unexplained celestial body has been sending out radio waves that have been pulsating toward Earth at a rate of 22 minutes. Scientists believe the object to be the energy-emitting pole of a dying star, but its rotation is so sluggish that it can't possibly exist. This object shouldn't be able to create radio waves if it's a magnetar, but we're seeing them, stated Natasha Hurl-Walker, a radio astronomer from Australia's Curtin University and the study's lead author. It is a cosmic lighthouse that defies logic. This object distinguishes itself because of its exceptionally slow speed and astonishing stability, earning it the scientific designation of GPM J3910. Radio signals that recur in space are not unexpected by astronomers, but the rate at which they often do so is significantly higher. Superdense structures that pack billions of tons of stuff into tiny microscopic areas. Neutron stars form when stars collapse at the conclusion of their lives. Radiant beams of energy and light are emitted by the magnetic poles of certain neutron stars, like the light from a lighthouse flashing to a boat offshore. We only receive the signal when the beam sweeps across our planet. The initial scientists who noticed these blips on Earth mistakenly believed they were messages from extraterrestrial beings because of how consistently they occurred. However, they have since discovered that these are the last gasps of a dying star that are emitted into space as a beam. Researchers anticipate that pulsing neutron stars will gradually decrease in speed until they encounter a theoretical limit called a death line. Beyond this limit, the stars will eventually collapse due to their insufficient mass. When the pulses become slower and more spaced out than a few minutes, it is generally considered that this barrier has been crossed. The scientists discovered that the pulses emanating from GPM occurred every 22 minutes. Surprisingly, each of them might persist for as long as 5 minutes. Our newly found object spins at a rate that prevents it from emitting radio waves. Although a very sluggish object similar to this one had been seen before, it pulsed every 18 minutes or so. The group speculated that the neutron star with the strong magnetic fields, known as a magnetar, was the source of the beams. However, GPM possessed an additional surprise that defied scientific expectations. Global observatories had been picking up this object's pulses for years without noticing a thing, and they were beaming out at the exact same time every 131.18.1.1957 seconds, give or take a tenth of a millisecond. This goes against what we know about neutron stars. These are expected to die out in months. For instance, the 2018 object only blazed for a short while between January and March 2018. However, the first record of GPM pulses dates back to 1988, about 33 years ago. The object may represent an entirely novel class of star systems. If this is the case, this is absolutely remarkable. Regardless of the mechanism, scientists find cosmic anomalies beginning to consider the possibility that there may be alternate means of producing a brief radio burst. The burst, initially identified as FRB 20201, was found in January 2020 by researchers using the Canada Hydrogen Intensity Mapping Experiment, CHIME, telescope, which has been a very effective tool for discovering FRBs. The number of known quick radio bursts has surged from less than 30 in 2017 when CHIME went online to well over 1,000 currently, thanks to the telescope. Instead of exploding once and then vanishing like 22 other bursts, FRB 20201 is a repeater, a type of space engine that produces several audible radio blasts. Over the next 3 years, scientists were able to pinpoint the FRB in the sky thanks to its bursts. Even if they weren't as brilliant as those coming from the farthest corners of space, from there, the group could attempt to track down a source because the burst measurements pointed to the proximity of FRB 20201. Ruled out dwarf galaxies as a possible source, therefore, they are not from those. With each new discovery, astronomers narrow the field of possible explanations for these mysterious signals. While scientists keep digging into the signal and experts say there's almost certainly a mundane Earth-based explanation, the mere hint of alien life is enough to get people excited. Following the start of Project OSMA, astronomers have been keeping a close eye out for radio signals that could be man-made instead of the radio waves that the universe produces on its own. These extraterrestrial symbols are thought to be more like the broadcasts that people use to communicate. A narrow range of radio frequencies would be all that these communications could use. A unique drift that shows the source is moving toward or away from Earth would further imply that the radio source is coming from a distant celestial body, like a planet in orbit around a star. Technology developed by humans seems to be the sole source of signals such as those because our Wi-Fi, cell towers, GPS, and satellite radio all appear just like the signals we're searching for. It's quite difficult to tell them apart from signals from space and those created by humans. Over the years, astronomers have discovered numerous signals that could be signals. It turns out that some of them came from celestial bodies that have not yet been located, such as pulsars, which are radio waves emitted into space by rapidly spinning dead stars. It seems like artificial signals were the first known short radio burst, per-tin signals, which are weaker bursts of radio emission, first baffled scientists until they linked them to microwave ovens. Many things could be causing BLC-1's unusual transmission: an unidentified satellite, an aircraft passing overhead, a transmitter on the ground in close proximity to the telescope's field of view, or even something more mundane like malfunctioning electronics in a nearby building or a moving vehicle. Like the famous WOW signal picked up by Big Ear, the Ohio State University Radio Observatory in 1977, there are signals that astronomers still haven't figured out how to explain as coming from the natural world. At first, this extremely bright radio wave barrage seemed to be a real eureka find, however, no one has been able to verify or find it since. With backing from Silicon Valley tycoon Yuri Milner, Breakthrough Listen embarked on a 10-year hunt in 2015, but their sky scans have yielded no tangible discoveries as of yet. The Parkes telescope was pointed toward Proxima Centauri in April 2019 by Breakthrough. This wasn't done to hunt for alien life so much as to better understand the massive flares that tiny red dwarf stars like Proxima often release into space. While reviewing those data, Shane Smith, a student at Michigan's Hillsdale College who is involved with Breakthrough, saw what seemed like BLC-1 was coming out of the star. Despite its obscurity, BLC-1 passed all of the tests run by the Breakthrough team to weed out the millions of signals generated by humans. These tests revealed that the signal had a narrow bandwidth, appeared to fluctuate in frequency, and disappeared when the telescope was pointed away from Proxima. Although several of the subsequent signals were determined to be radio interference, 4 of them did emerge. The possibility of extraterrestrial technology is quite encouraging to our algorithm. The fact that this is the algorithm's first significant discovery makes it all the more thrilling, claims the SETI Institute's Seth Shostak. If BLC-1 is, against all odds, a postcard from the star system next door, although it may seem like a lot, this scenario would mean that our galaxy is home to around 500 million civilizations. The crew has revisited Proxima Centauri since the discovery, but thus far, no new information has been uncovered. Scientists are coming up with additional tests to determine where the signal is coming from, and they are also keeping the Parkes telescope pointed at Proxima. The existence of explosive bursts in the cosmos beyond our galaxy is now confirmed. More and more fast radio bursts will be located in their host galaxies as more and better telescopes join the search. To make ASCAP 5 times more sensitive and extend the frontier of our research further into the universe, we are now creating a new fast radio burst search system. And as time goes on, increasingly distant bursts will be detectable by ultrasensitive radio telescopes like the Square Kilometre Array. Indeed, astronomy is constantly being propelled ahead by the inquisitiveness and optimism surrounding the possibility of discovering extraterrestrial life. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.